Hello everybody, this is your host, and in this video, we're going to be talking about how to measure your algorithm's performance. It is a crucial thing to do, so let's get started with it right now. Alright everybody, here we are. So what we're going to talk about in this video is exactly how you can measure the performance of your algorithm. So this is very important because sometimes you have an algorithm that works very well for a certain period of time, and then all of a sudden something happens. Maybe the data changes, or maybe the way the problem is being asked is changing over time. For example, if you are solving a computer vision problem and images are becoming more challenging to solve, you know that your algorithm might not be performing as well as before, even though you've used the same training pipeline. That is why you need to measure the performance of your algorithm and make sure that it is up to scratch. We will also discuss some of the tips and tricks that you can use to visualize the results so that they become more understandable and you can easily take action upon them. So let's get into it. The first thing you want to do is import matplotlib and make sure that you have it set up properly in your environment. Then you want to make sure that you can actually access your metrics from the training process. So if you are not using any library and you are just implementing your own training loop, you need to save the performance metrics in some kind of file system or database so that you can access them later on. In this case, I am assuming that you are using TensorFlow or Keras. So we can simply say model, evaluate to evaluate the model on a validation set. And once we do that, we can see that the loss and the accuracy has been printed out. However, we want to save them. So what we're going to do is we're going to store the history in a variable called history, which is available after the training process. Now we can access the loss and the accuracy by saying history.history. So history is a dictionary-like object that has different keys for different metrics. In this case, we want to access the loss and the accuracy. So we're going to pull those two values out. You can also access the number of epochs and the number of steps per epoch if you need them. Now that we have everything we need, we can import matplotlib and plot the results. The first thing we want to do is figure. That is the parent object that contains both the axes and the labels and titles. So we're going to call that. And then we're going to say subplot to 1 because we want to have the subplots vertically stacked. And we're going to start at index 1. Then we're going to plot the accuracy. So we're going to say plot. But before we do that, we need to take the validation accuracy and the validation loss because those are the ones that we have evaluated on the validation set. So we're going to say validation accuracy, which is equal to the accuracy, and then the range of the number of epochs. And then we're going to label this as the accuracy. We're also going to add a legend and set the title. So that's basically the accuracy over the number of epochs. Then we're going to move on to the second subplot, where we're going to be plotting the loss. And we're going to do pretty much the same thing. So we're going to say subplot, but this time we're going to say to because we want the second one, and then we're going to plot the loss. So loss this time. And then again, we're going to label the axes and set the title. Now that we've created all the subplots, we can show them all by calling show. You can also use other libraries such as TensorBoard to visualize your losses and your accuracies. And if you want to learn how to do that, I highly recommend that you check out the guide that I wrote about how to use TensorBoard in depth. However, for the purpose of this video, we're just going to stick with matplotlib and show you how you can visualize the confusion matrix and the precision, recall, and F1 score. Let's start with the confusion matrix. We're going to use the built-in function from Sclern metrics called confusion_matrix and pass the true labels and the predicted labels to it. We don't really care about the classes or anything like that. We just want to get the confusion matrix as a numpy array, and then we can use matplotlib to plot it. So we're going to say figure, and then we're going to say imshow. And this time we want to pass the confusion matrix to it. So we're going to say conf_mex, which is the confusion matrix. And we're also going to use anit to annotate each cell with its value. And then we're going to label the axes and set the title. In this case, we want to annotate the confusion matrix, which means we want to write the numbers inside the cells. Finally, we're going to plot the precision, recall, and F1 score. So we're going to import precision_score, recall_score, and F1_score from sklearn.metrics. Then we're going to apply these functions to the true labels and the predicted labels and store them in a variable called scores. Now we can plot them individually by using bar charts. So we're going to say figure, and then we're going to say bar. And we're going to pass the x and the y coordinates to it. And we're going to do this 3 times, once for the precision, once for the recall. and one's for the F1 score, and we'll label each of them appropriately. In addition to that, we can also plot the learning curves. Learning curves basically show you how the training loss and the training accuracy compared to the validation loss and the validation accuracy. If the training and validation curves are close together, that means that the model is not overfitting. So in this case, we are going to plot the training loss and the training accuracy in blue and the validation loss and the validation accuracy in red. To do that, we are going to create a figure, and then we are going to say hold on so that we can plot multiple things on the same axis. Then we're going to plot the training loss and the training accuracy. So we're going to say plot. At this time, we are going to pass the training loss and the training accuracy as the y and the x coordinates. And we're going to label this as the training loss and the training accuracy. And we're going to color it in blue. Then we're going to plot the validation loss and the validation accuracy. So we're going to say plot again, but this time we're going to pass the validation loss and the validation accuracy. And we're going to label this as the validation loss and the validation accuracy. And we're going to color it in red. Finally, we're going to set the title of the plot. So let me ask you a question. What do you think is the best practice here? Is it okay to print the metrics directly as we did in the beginning of the video, or is it better to plot them and visualize them so that you can have a better understanding of how your model is evolving over the course of the training process? Let me know your thoughts in the comments below. If you enjoyed this video, make sure to let us know by giving us a thumbs up, and don't forget to subscribe so that you can be notified when we release new videos. Thanks for watching, and we'll see you in the next one.